Today we're going to practice solving quadratics using the OMG Math method. The first problem we're given is x squared plus 5x plus 4. What we observe is that we are given a quadratic. Our mission is to find the values that make the equation equal 0, since it asks us to solve. And our game plan is going to be to factor and solve this one. So when we go through and factor this, on a previous video, we learned how to factor using the grouping method. When we factor using the grouping method, we get that this factors down into x plus 4 times x plus 1. If we want to do a quick check, x times x gives us x squared, x times 1 gives us 1x, 4 times x gives us 4x, and when we add those together we get 5x's, and 1 times 4 is 4. So we've done a quick check to make sure this is the correct factored form. Once it's in factored form, to solve, since we're setting the equation equal to 0, we take each factor separately, set it equal to 0, and solve for x. For the first one, to get x alone, to undo a plus 4, we subtract 4. 4 minus 4 is 0, so that cancels, leaving us with x equals negative 4. Over here, to get x alone, we're adding 1, so we're going to subtract 1, so those will cancel. 1 minus 1 is 0, so that cancels out, and I'm left with x equals negative 1. So I found my two zeros. Since it was a quadratic formula, I was looking to get two zeros since the power here is 2, so I finished this first problem. The next problem, what I recognize is that I'm also given a quadratic equation and asked to solve. The mission for this one is going to be the same. Find the x values that make the equation equal 0. That'll always be your mission when it asks you to solve a quadratic. Our game plan for this one, instead of factoring and solving, we're going to use quadratic formula. We're going to take the equation 5x squared plus 6x equals 1 and set it equal to 0. So we subtract 1 from both sides, which leaves us with 5x squared plus 6x minus 1 equals 0. Once we have it in this form, we can apply the quadratic formula. So I'm going to use 5 as my A, 6 as my B, and 1 as my C, and plug it into the formula. It's going to be negative 6 plus or minus the square root of 6 squared minus 4AC all over 2A. It's going to simplify to be 6 plus or minus 6 squared is 36. I'm going to treat this 4 as if it was negative, so negative 4 times 5 times negative 1 is a positive 20 all over 10. That gives us negative 6 plus or minus the square root of 56 all over 10. I know square root of 56 is not a perfect square, but I'm going to see if I can reduce it. So square root of 56 breaks down into 2 and 28. 28 breaks down into 2 and 14. 14 breaks down into 2 and 7. When I am simplifying a radical, I can only pull out pairs, so I have a pair of 2's. So that's going to simplify to negative 6 plus or minus. I have a pair of 2's I can pull out. This 2 and 7 could not come out, so I go back inside the parentheses. 2 times 7 leaves me with 14 inside, and this is all over 10. Once I'm at this point, if I want to simplify this, I know that negative 6, 2, and 10 are all divisible by 2, so I'm going to divide each of these by 2. 6 divided by 2 is going to be negative 3 plus or minus. 2 divided by 2 is 1, so I'm going to let that cancel itself out. Square root of 14 cannot be divided. You can't divide inside a radical. 10 divided by 2 is 5. So my answer is negative 3 plus or minus square root of 14 all over 5. The last problem I'm going to do is set up the same way. I'm given a quadratic. My goal is to find the x values that make the equation equal 0, and again I'm going to use quadratic formula. So I know that this is my A, my B, and my C value. So I'm going to write it out. if my b value is negative, when I plug in negative b, and b is negative, the negatives cancel out, so I get 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all over 2 times a. Although there's no a value given, we know that there's always a 1 here, so that's why I'm plugging in negative 1. This is going to simplify to be 4 plus or minus. 4 squared is 16. Again, treat this 4 like a negative, so negative 4 times negative 1 is positive 4, times negative 10 is negative 40. On the bottom, 2 times negative 1 reduces to negative 2. So then I have 4 plus or minus the square root. 16 minus 40 is negative 24, all over negative 2. Then I take this and simplify it even further. 4 plus or minus, square root of 24 is not a perfect square, so I see if 24 can simplify, which it can, into 4 and 6. 4 reduces to 2 and 2. 6 reduces to 2 and 3. Again, when we're simplifying radicals, we can only pull out pairs. So we pull out a pair of 2's, and then we leave 6 inside because 2 and 3 could not come out, so we multiply those back together. One thing we need to note is that this is a negative inside the radical, and we cannot have negatives. So we pull out the negative as an I, and everything becomes positive. And then we write the bottom, which is negative 2. Then from here, 4, 2, and 2 can all be simplified. So I'm going to divide 4 by 2, which becomes 2, plus or minus 2 divided by 2 becomes 1. So I'm just going to let those cancel out, over 6. And then negative 2 divided by 2 is negative 1. So here is my answer for this one. This is a correct answer. The most correct form would be then to take this negative 1 and divide each piece by negative 1, which will leave us with negative 2 minus I square root of 6, and negative 2 plus I square root of 6. These are our two answers. And we have learned how to solve 3 different scenarios of quadratic equations with 3 different types of answers. For the first problem, we got 2 rational answers. Rational answers are numbers that can be written as fractions. For our second answer, we got 2 irrational answers. These are written as square roots. And for the last problem, we have complex solutions because we have i's in the solutions. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.